This video was actually suggested in the comments of another video, so thank you Billy for your suggestion. I've looked at the very small scale of the universe. What about if I go the other way and have a look at the large scale of the universe? What's out there? Let's find out more. I'm going to start off with the SI base unit of length, which is the metre. I'll try and do as many conversions to imperial units as I can, but I'll stop once I get to the light year. I'm going to go up in scale, looking at both the size of objects and distances involved as we go from the metre upwards. This is also going to be my longest video to date, so bring snacks. Let's get on, shall we? So to start, we have the metre. This is 3.28 feet, and the standard measurement of length in the SI system. It was originally defined as 1/10,000,000th of the distance from the North Pole to the equator. After a number of redefinitions, it was finally defined in 1983 as the distance light travels in 1/299279245 of a second. In fact, we've now set the speed of light so that any revisions of the speed of light wouldn't change the speed of light itself, they'd alter the size of a metre. There are a lot of everyday objects that are about a metre in size. Average human height differs depending on a number of factors, but an average human male from the UK, which is where I'm from, is about 1.75 metres tall. Giraffes are a little taller, reaching 5.2 metres in height, and just a little taller we find Paraceratherium, the tallest land mammal ever to live. It roamed across Europe and Asia some 30 million years ago. In terms of distance, 1 metre is a large step, or a little wheel if you're a wheelchair user, away from where you currently are now. Let's go 10 times bigger to 10 to the 1 metre, or 10 metres. A telephone pole is about 10 metres tall, and the Leaning Tower of Pisa is 55 metres tall. In terms of distance, if you were to travel across a doubles tennis court, you'd move 11 metres. Walking along the length of a cricket pitch, I am British after all, would have you moving 20 metres, and the distance between bases in a baseball game is just a little longer at 27.43 metres. Coming up a little in size, let's go to 10 to the 2 metres or 100 metres. Some asteroids are around 100 metres in diameter, including an asteroid called Dimorphos. This is the moon of a slightly larger asteroid called Didymos. Dimorphos is about 170 metres in diameter, while Didymos is about 800 metres in diameter. They actually form a binary system together. Dimorphos is notable because in September 2022, NASA smashed a spaceship into it to see if they could alter its orbit at all. The idea being that one day we might need to if a large enough asteroid comes within striking distance of Earth, and initial findings suggest that we did. The impact slowed Dimorphos sufficiently for it to move into a lower orbit around Didymos. In terms of distance, 100 metres is the distance of the shortest outdoor Olympic track event. Some people can run 100 metres in under 10 seconds, though most of us take a little longer. Let's go up a bit in size, but still at very manageable sizes, to 10 to the 3 metres, or 1,000 metres, which is a kilometre. This is about 0.62 miles. In the outer region of the asteroid belt between Mars and Jupiter, there's an asteroid family. Asteroid families have some similar properties and are thought to come from the same origin. This asteroid family, called Coronis, which is thought to have come from a collision of two larger bodies about 2 billion years ago, contains an asteroid called 243 Ida. But it isn't this asteroid I'm actually interested in. This asteroid has a moon called Dactyl. Dactyl isn't exactly a sphere, but it isn't far off. This asteroid moon, the first to ever be confirmed, is about 1.4 kilometres in diameter. In terms of distance, if you were to travel between the towers of the Golden Gate Bridge in San Francisco, you'd have travelled a distance of 1.28 kilometres. Let's increase our size by another 10 times to 10 to the 4 metres. This is 10,000 metres or 10 kilometres. The moons of Mars are about this size. The smaller one, Deimos, has a diameter of about 13 kilometres, whilst the bigger moon, Phobos, has a diameter of 22 kilometres. Neutron stars also have a diameter between 10 and 20 kilometres. In terms of distance, if you were to walk, or cycle, all the way around the Large Hadron Collider at CERN, you'd cover a distance of 26.7 kilometres. Working at its fastest, particles will travel round this ring over 11,000 times per second. These particles are travelling at over 99.9% the speed of light. Going up another order of magnitude to 10 to the 5 metres, that's 100,000 metres or 100 kilometres, there are a number of asteroids that have a diameter of 100 kilometres, including 5 Astraea, an asteroid belt body with a diameter of 119 kilometres. In terms of distance, 100 kilometres is officially the point above sea level where space begins. We call this the Kármán line. This rather arbitrary line determines whether a craft is an aircraft or a spacecraft. The International Space Station orbits the Earth at a distance of 408 kilometres. Let's go up another order of magnitude to 10 to the 6 metres, which is 1,000,000 metres or 1,000 kilometres. That's about 620 miles. In terms of size, we're now talking roughly the size of moons. The moon of Saturn, called Tethys, has a diameter of roughly 1,062 kilometres. Tethys is composed mainly of water ice with just a small component of rock. Our own moon has a diameter of about 3,470 kilometres, and the largest moon in the solar system, Ganymede, has a diameter of about 5,270 kilometres. In terms of distance, we are still very much earthbound, with the distance from London in the UK to Madrid in Spain being 1,262 kilometres. Going up another order of magnitude, we get to 10 to the 7 metres, or 10 million metres, that's 10,000 kilometres, and that's about 6,200 miles. Most of the planets in the solar system have diameters in this sort of range. Some slightly smaller, like Mars, and some slightly bigger, for instance Earth and Venus, and some quite a bit bigger, like Uranus and Neptune. In terms of distance, a flight from London to Tokyo is 9,559 kilometres, so very nearly 10,000 kilometres. Up another order of magnitude to 10 to the 8 metres, and this is 100,000 kilometres, or about 62,000 miles. The largest planets in the solar system are in this range of sizes. Saturn has a diameter of 116,460 kilometres. Jupiter is a little larger, with a diameter of 139,820 kilometres. Some stars are only just a little bit bigger in diameter than Jupiter. The nearby star of Wolf 359 has a diameter of just 200,000 kilometres. It's only about 40% bigger than Jupiter, but it's got a mass about 100 times as much. In terms of distance, 100,000 kilometres is a bit over a quarter of the way from the Earth to the Moon. A number of moons in our solar system are about 100,000 kilometres from their parent planet. Metis, the innermost moon of Jupiter, lies about 128,000 kilometres from the Jovian giant. This moon lies within Jupiter's ring system, and along with a few other moons, seems to be the source of a lot of the ring material. It's made largely from water ice, and it would seem as though it's very elongated and reddish in colour. It lies just outside the Roche limit, meaning if it was much closer to Jupiter, it would be ripped apart by the gravitational forces exerted on it by the planet, and would become just more matter making up Jupiter's thin ring system. Let's go 10 times bigger and see what we find at 10 to the 9 metres, which is 1 billion metres or 1,000,000 kilometres. That's about 620,000 miles. What kinds of objects are this size? Well, our Sun and a number of other stars are about 1,000,000 kilometres in diameter. Our Sun is actually 1,393,000 kilometres in diameter. And our Sun is just an average star, which just so happens to have the only place in the known universe to harbour life. In terms of distance, 1,000,000 kilometres is nearly 3 times as far as the Moon. The Saturnian moon, Titan, orbits 1,221,000 kilometres from the ringed giant. Moving away from our solar system, the stellar system of TRAPPIST-1 contains a small red dwarf star and a number of rocky planets. The innermost of these orbits the star at just 1.7 million kilometres. In fact, all 7 planets orbit the star at distances below 10 million kilometres. Let's go 10 times bigger and move to 10 to the 10 metres. This represents 10 million kilometres, or about 6.2 million miles. Some larger stars are around this size, including Pollux, which is nearly 10 times bigger than the Sun, and Capella, Arcturus, and Aldebaran. It also includes the wonderfully named BAT 99-98, a Wolf-Rayet star, which is about 38 times the diameter of the Sun and 5 million times brighter. In terms of distance, the orbit of Mercury around the Sun is about 58 million kilometres, about 36 million miles. Let's go at 10 times bigger to 10 to the 11 metres. This is 100 million kilometres, 62 million miles. There are some larger stars that are around this big. These include Rigel, Deneb and Wiesen. In terms of distance, the orbits of the Earth and Mars fall within this range. The Earth orbits the Sun at about 150 million kilometres. That's about 93 million miles. Mars has an orbit of 228 million kilometres, or 141 million miles. Up another 10 times bigger, and now at 10 to the 12 metres, or a billion kilometres, we find some of the largest stars in the known universe, including Betelgeuse, VY Canis Majoris, UY Scuti, and the largest known star at present, Stephenson 2-18, with a diameter 2,150 times larger than the Sun. In terms of distance, Jupiter has an orbit which is 778 million kilometres, and the orbit of Saturn is 1,427 million kilometres. In fact, the orbit of all the rest of the major planets in the solar system falls within this range, with the orbit of Uranus being 2.9 billion kilometres and the orbit of Neptune being 4.5 billion kilometres. The orbit of the minor planet Pluto comes in here with an average value of 5.8 billion kilometres. Let's go 10 times bigger and up to 10 to the 13 metres. This is 10 billion kilometres, and now we're getting to truly huge objects. One of the largest single objects ever discovered is the supermassive black hole at the heart of the galaxy NGC 4889. This black hole is estimated to have a mass equivalent to 21 billion suns. Lower estimates of its event horizon are in the region of 20 billion kilometres, about 4 times bigger than the orbit of Neptune. In terms of distance, we have a truly wonderful piece of human ingenuity here. The Voyager 1 spacecraft is the farthest human-built object in existence. NASA actually have a web page showing its mission stats, and when I looked at it, it was 23,841,000,000 kilometres from Earth, travelling at an estimated 17 kilometres per second. Up another order of magnitude to 10 to the 14 metres. This is 100 billion kilometres. And here we come to what's possibly the single largest object in the known universe. Everything on my list above this size are amalgamations of smaller objects like nebulae and galaxies and so on. Phoenix A is a truly immense black hole at the centre of the Phoenix galaxy cluster. It has an estimated event horizon of 590 billion kilometres in diameter. In terms of distance, if we're moving away from Earth, we've gone way past the orbits of all the planets. We've even gone through the Kuiper Belt, a disk of minor planets and asteroids extending from around 4.5 billion kilometres out to about 7.5 billion kilometres. At roughly 3 times 10 to the 14 metres, we find the inner edge of the Oort cloud. The Oort cloud is a huge cloud of icy planetesimals. Unlike the Kuiper Belt, which is a flattened disk in shape, the Oort cloud has 2 regions. The inner region is a torus shape, and an outer region which is spherical. The outer region especially is only just gravitationally bound to the Sun, and it's thought that a number of comets in the solar system started off as chunks of ice in the Oort cloud. Gravitational disturbances seem to cause these to hurtle in towards the inner solar system. Let's go up 10 times bigger to 10 to the 15 metres. This is 1 trillion kilometres, and here we find the first of our nebulae, NGC 7027, or the Jewel Bug Nebula. It's the smallest nebula we've discovered. Many nebulae are formed as a result of supernova explosions, with the dust clouds forming from the blown off outer layers of the dying star. This nebula lies about 3,000 light years away and is just 600 years old. That accounts for its small size at just 0.1 by 0.2 light years in size. 10 to the 15 metres is about 0.1 light years, and in terms of distance, moving away from the Earth, we're still in the Oort cloud. Yes, the Oort cloud is seriously big. If we go up another order of magnitude to 10 to the 16 metres, it's here that we'll find the light year. Well, nearly. A light year is just slightly smaller than 10 to the 16 metres. 1 light year is in fact 9.5 times 10 to the 15 metres. So what can we find that's about a light year in size? Some nebulae are about a light year across. Nebulae come in a number of different types. Some of them are formed from supernova explosions of massive stars. Some nebulae contain dust and gas that will collapse under its own gravity, until eventually it leads to the formation of a new star and orbiting planets. The Helix Nebula is a planetary nebula and is one of the closest, if not the closest, nebula to Earth. It has a diameter about 5.5 light years and lies about 650 light years away, and was formed as a relatively small star came to the end of its life. As it did, it shed its outer layers, which then became the dust and gas which makes up the nebula. At its core lies the remains of the star, destined to become a white dwarf, one of the strangest and most intriguing objects in the universe. In terms of distance, we're now starting to get to other stars. At a distance of roughly 4 light years, we find our nearest stellar neighbours in the Alpha Centauri system. These 3 stars contain our actual nearest neighbour, the red dwarf Proxima Centauri. In fact, there are up to 10 other stellar systems closer than 10 light years from us, including Barnard's star, the brown dwarf pair of Lumen 16, WISE 0855, Wolf 359 and more, all lying within 10 light years from here. Now on up to 10 to the 17 metres, that's roughly 10 light years. With a diameter of about 11 light years, we find the beautiful Crab Nebula. This nebula was formed as a result of a supernova explosion and actually appears to be the remnants of a supernova observed by Chinese astronomers in 1054 AD. And this was actually the first object to be identified as coming from a supernova explosion. So immense are supernovae that the dust and gas ejected during the explosion are still hurtling outwards at 1500 kilometres per second. At the centre of the nebula is the Crab Pulsar, a neutron star about 30 kilometres in diameter. In terms of distance, we find lying 10.3 light years away the red dwarf star Ross 248. We're still very much in our local galactic vicinity. Some other notable stars at similar distances include Altair at 16.7 light years. This star is nearly twice the mass and has 1.5 times the radius of the Sun, and is nearly 11 times more luminous. Altair also spins very quickly, making a complete rotation in just 8 hours. For comparison, our Sun rotates once in about 25 days. This has the effect of squashing Altair at the poles and expanding it around the middle. Let's go up another 10 times bigger to 10 to the 18 metres. That's roughly 100 light years. So objects in the universe are about 100 light years in size. Well, we're here in nebula territory. We've not quite reached the size requirements for galaxies yet. Nebulae can be truly immense objects, though to call them objects is a little bit of a stretch. They're associations of dust and gas, much more dense than the surrounding vacuum of space, but very tenuous indeed. They contain maybe several hundreds to several thousand molecules per cubic centimetre, maybe even a few million molecules. That may seem like a lot, but it's actually more devoid of molecules than any vacuum we can create here on Earth. The Veil Nebula, located in the constellation of Cygnus, is a nebula formed from a supernova explosion sometime between 10 and 20,000 years ago. It has a diameter of about 130 light years. I did say that we're not quite in the size realm of galaxies yet. Well, that's not quite true. It's around this size that we find our very first galaxy, called Segway 2. And this is one of the smallest, if not the smallest galaxies ever discovered. It lies 110,000 light years away and is a satellite of our own Milky Way galaxy. This dwarf galaxy has a diameter of just 220 light years. That's not quite true. It has a half-light diameter of about 220 light years. This means that half the light emitted from the galaxy is emitted from this portion 220 light years in diameter. The actual galaxy itself will be bigger, but probably not a great deal bigger. Segway 2 is interesting because many of its stars are more than 12 billion years old. These are some of the first stars ever to form in the universe. We currently don't think that there's any active star formation happening anywhere in this entire galaxy. In terms of distance, we have plenty of stars to choose from. There are over 250,000 stars lying within 1,000 light years from Earth. A couple of notable ones are Canopus, lying 310 light years from us. This is a huge star with a radius 73 times that of the Sun and a luminosity nearly 11,000 times as much. This star has come to the end of its hydrogen burning phase and has expanded as a result. In fiction, the third planet orbiting Canopus is known to us as Arrakis, or Dune. Lying about 550 light years away, we find the even more massive star Antares, or more specifically, Antares A. This star is a massive red supergiant, about 680 times bigger than the Sun. If it was placed in our solar system, Antares A would swallow up Mercury, Venus, Earth, and Mars. Let's go 10 times bigger to 10 to the 19 metres. That's roughly 1,000 light years, and we now come to some of the largest nebulae. The Tarantula Nebula lies about 160,000 light years away, and the nebula itself covers a massive 1,800 light years. This nebula actually lies outside our galaxy in a nearby galaxy called the Large Magellanic Cloud. This and a number of other bodies are satellite galaxies of our own. The Tarantula Nebula is a region of active star formation, and this is known as a starburst region. In fact, the Tarantula Nebula has one of the highest rates of star formation in the local group of galaxies. The dwarf galaxy Sextans A, which is located about 4.3 million light years away, has a diameter of about 5,000 light years. This is a weird galaxy in that it looks square from here on Earth. Also, a lot of the stars look blue. This was caused by massive short-lived stars dying in supernova explosions, and this resulted in more star formation, which resulted in more supernovae, and so on. The blue stars that we can see are young, newly formed stars, well, young in galactic terms anyway. Let's move up another factor of 10 to 10 to the 20 metres. That's roughly 10,000 light years. And there are some galaxies that are about this size. The M33 Triangulum galaxy, which lies 2.7 million light years away, is about 60,000 light years in diameter. At about the same size, being 61,000 light years in diameter, but lying much further away at 31 million light years, we find M104, also known as the Sombrero Galaxy. This galaxy is given its distinctive look by a large ring of dust that crosses the central bulge of the galaxy. In terms of distance, we're not quite able to reach any other galaxies yet. Well, nearly, but a bit more about that in a minute. The supermassive black hole at the centre of our galaxy, called Sagittarius A star, is located 26,700 light years away. The Milky Way galaxy has a number of smaller satellite galaxies which orbit our galaxy. One of these satellites is the dwarf galaxy Segway 1, and this is a dwarf galaxy satellite of the Milky Way lying about 75,000 light years away. Up another multiple of 10 we get to 10 to the 21 metres. This is very roughly equal to 100,000 light years, and we're now well into galaxy territory. The Milky Way galaxy in which we live has a diameter of about 100,000 light years. Here we also find the enigmatic Hoag's object. This is a galaxy containing an older nucleus of yellow stars surrounded by a ring of young blue stars. In terms of distance, there are many dwarf galaxies that are satellites of our own Milky Way galaxy. Many of these lie at about 100,000 light years from Earth. These include the aforementioned Segway 2 at about 110,000 light years, also the small and the large Magellanic Clouds, the Draco dwarf galaxy at 260,000 light years, and lots more. These dwarf galaxies orbit around the Milky Way and happen to be in our local-ish neighbourhood at the moment. Up another order of magnitude to 10 to the 22 metres, which is about 1 million light years. We're now in the size territory of the largest known galaxies in the universe. ESO 306-17 is a giant elliptical galaxy about 1 million light years in diameter. It is thought that this galaxy swallowed up all of its near neighbours as it sits in the middle of an empty space, nearly 500 million light years away. In terms of distance, the Andromeda galaxy lies about 2.54 million light years away. This galaxy is a little bigger than our own galaxy with a diameter of about 150,000 light years. The Milky Way and the Andromeda galaxies are on a collision course and will merge somewhere between 2.5 and 4 billion years from now. If we move up another factor of 10 to 10 to the 23 metres, this is about 10 million light years. Even though we've now looked at the largest of galaxies, galaxies organise themselves into clusters. One such cluster is called a local group. This consists of the Milky Way and Andromeda galaxies, which are quite large galaxies after all, and also the satellite galaxies of both of these main galaxies. The local group is a kind of dumbbell shape, with the Milky Way and Andromeda at either end, and the satellite galaxies in a cloud around them. The diameter of the local group is about 10 million light years. In terms of distance, what can we find that's 10 million light years away? Lying at 10.05 million light years away, we find the galaxy NGC 404. This galaxy lies in the Andromeda constellation. It also lies close, in viewing terms at least, to the star Metre. This has led to the galaxy being difficult to spot and photograph, and has been responsible for its other name, which is Mirac's ghost. Lying just a little bit further out at 12 million light years away, we find Messier 81. This is a bright galaxy at an oblique angle, which gives us an impressive view of the spiral of this galaxy. Due to its brightness, it's popular with amateur and professional astronomers alike. Getting 10 times bigger, we've come to 10 to the 24 metres, which is roughly 100 million light years. Our galaxy isn't just part of the local group. Galaxies come together in larger and larger structures called clusters and superclusters. The Milky Way galaxy is part of the Virgo supercluster. This consists of at least 100 galaxy groups and clusters, and spans a whopping 110 million light years. Structurally, the Virgo supercluster consists of a large elliptical disk which contains 2/3 of the galaxies. Surrounding the central flattened disk is a roughly spherical halo containing the remaining galaxies. The Virgo supercluster is only one arm of an even larger structure called the Laniakea supercluster, and this is the supercluster that the Milky Way galaxy belongs to. Laniakea contains approximately 100,000 galaxies and is about 520 million light years in size. These superclusters are some of the largest structures in the known universe. In terms of distance, about 250 million light years is the approximate distance to the Great Attractor, a supergiant structure hidden from view behind the Milky Way galaxy. Up another factor of 10 and we arrive at 10 to the 25 metres. This is roughly 1 billion light years, and here we have the most massive structures in the universe. At 1.37 billion light years, we find the length of the Sloan Great Wall. This is formed from a huge wall of galaxies located about 1 billion light years away. One more increase in size finds us at 10 to the 26 metres, or about 10 billion light years. Here we find the most massive structure ever discovered. This is called the Hercules Corona Borealis Great Wall. This is a wall of galaxies about 10 billion light years in length. In terms of distance, we have the most distant object ever discovered so far. This is a galaxy called GN-Z11, and it lies 32 billion light years away. This red smudge here is actually a galaxy filled with new blue stars. The image of this galaxy is as it existed 13.4 billion years ago, just 400 million years after the Big Bang. The smudge looks red because even though the stars in the galaxy are young and blue, their journey to us over the last 13.5 billion years has shifted the light towards the red end of the spectrum. We're nearly at the end of our journey at 10 to the 27 metres, or 100 billion light years. Just a little smaller than this, we have the diameter of the observable universe, which is about 93 billion light years in diameter. So what lies beyond that? Well, we just don't know. The universe may be infinite in size, and this is just the part of it we can see. You find me here at the end of our journey, relaxing. I've come to the distant, distant past, and have found a nebula. Slowly, almost imperceptibly, the gas and dust below me is moving together. Gravity is doing its job and moving the particles closer and closer together. Soon, well in galactic terms anyway, these particles will become so close and so dense that they will start to shine as a new star. Some other parts of this dust cloud will eventually form into planets. One planet in particular will become very important to us: Earth. If you enjoy my journeys of discovery in our enigmatic and fascinating universe, then please consider subscribing so we can go on more journeys together. And for now, and until next time, thank you for watching.